Good morning and welcome to today's webinar. We appreciate you taking time to join us today. My name is Sherry Sullivan and I'm with the AWS marketing team here in Seattle. I'm pleased to host today's webinar where you'll hear from AWS and Think Big Analytics, one of our advanced consulting partners, who will share their expertise and insights on how to develop big data applications and technologies on the AWS cloud. You'll also hear some best practices that insurance companies are leveraging when it comes to cloud and analytics to improve their business performance. Let's get started with just a couple of housekeeping items. This webinar will run for approximately 1 hour. Your lines have been muted. However, we invite you to add your questions into the Q&A dialog box anytime during this webinar. We'll take time at the end to answer your questions. I'd also like to remind you that today's webinar is being recorded and we will send you a link at the end of this session. In addition, you can find our AWS content. We'll post this on YouTube as well as SlideShare and make those available for on demand. So today's session, let's get started. We'll begin with Karan Bahati. He's our AWS Solutions Architect out of New York. And Karan will provide you with an overview of big data solutions on AWS, including an overview of Amazon Elastic MapReduce and Amazon DynamoDB. Followed by Dan Maliker, who is a Senior Data Scientist with Think Big Analytics, and Dan Eklund, Principal Architect. Dan will provide you with an overview of big data technologies, warehousing, and analytics, along with a case study on insurance companies and how they're managing big data in the cloud. So without further delay, I'd like to turn things over to you, Karan.
Good morning, everybody, or good afternoon. My name is Karan Bhatia. I'm a Solutions Architect with Amazon Web Services. I'm based here in New York City, and I'm happy to be here today and talk to you about our infrastructure as a service, and specifically about some of our tools for big data applications. You may be surprised to hear that Amazon provides big data tools. Some people know Amazon as the online, or most people know about Amazon as the online retailer, the world's largest bookstore. But Amazon really has 3 core businesses: the retail business that sells books and diapers and everything else, a seller's business that provides tools to the other retailers from payment systems to fulfillment services, and Amazon Web Services, sometimes called infrastructure as a service or cloud computing. So how did Amazon get into the cloud business? Well, as Amazon.com, the retailer, grew, we had to address many of the core challenges involved in building large-scale distributed systems: scalability, elasticity, and resilience among them. We encapsulated those solutions in web services or programmatic APIs and made them available to any developer, and were amazed to see how fast they were adopted. S3, our object storage, for instance, was one of the first AWS services, and today it has over 1 trillion objects stored. And that's because it solves a very basic but hard problem. How do you reliably store and retrieve data without having to worry about running out of space, without having to worry about tape backups, or bandwidth scalability? We like to say that AWS deals with all this infrastructure muck so that you can spend your time on your business problems. Now, some have said, and it's absolutely not the case, that AWS is simply the unused compute capacity of Amazon.com, the retailer. AWS, Amazon Web Services, is a separate business, and in fact, Amazon.com is a customer of AWS and is not even the largest customer. AWS has hundreds of thousands of customers, everyone from Netflix to Foursquare to name your favorite startup. In the enterprise as well, AWS has made significant inroads. Recently, NASDAQ and AWS announced a partnership called FinCloud. It's powered by AWS and provides management, storage, and analytics of financial data mandated by regulation. And we continue to grow. We're adding compute capacity every day equivalent to the server capacity of Amazon.com, the retailer, when it was a $2.7 billion company. The Amazon Web Services infrastructure is global. We have regions all over the world, in Europe, North America, South America, and Asia. On top of this global infrastructure is our core foundation services, compute, storage, and networking. We provide higher-level tools such as parallel processing, content distribution networks, and others as well. And finally, we provide identity management, deployment and monitoring services, and all of our services are accessible through programmatic interfaces. So you can integrate your applications and tools to build highly available, elastic, and responsive applications for your customers. So here's a picture of our global footprint. The yellow square boxes represent regions. We have 8 regions. Each region is comprised of multiple data centers, what we call availability zones. Each availability zone in a particular region has separate physical infrastructure from other availability zones within that region. We have separate power, separate cooling, networking, and in fact, each availability zone is located in a different floodplain. So a couple points. When you launch services, infrastructure services with AWS, you pick which region you want to use. So for example, if you want to spin up a compute server, you specify the region and the availability zone you want to run in. You can replicate your data across regions, replicate your databases or your clusters, but we don't do that for you. You have to do that explicitly. So if you use a particular region, you're ensured that all your data and services are going to remain within that region. Our services within a region are all multi-AZ. So we provide high availability through the use of multiple availability zones for our services. So for example, if you use Elastic Load Balancer, it runs across multiple data centers or multiple availability zones, and that's what we recommend as you build out your services as well for your customers. For disaster recovery, you might consider a multi-region approach to deal with that. We also have a growing number of CDN or Content Distribution Network edge locations represented by the red dots. I won't talk too much about that in this talk, but if you're interested, it's called CloudFront, and it's a great service. So today, I'm going to focus on tools that we provide related to big data analytics. In particular, tools that help you collect, store, analyze, and share large data sets. As with all of our core compute and data services, these big data tools provide the same economics. There's no upfront cost. It's a self-service infrastructure. You pay for what you use. You shut it down, and there's no further cost. You can easily scale up and down depending on your need. And all of that is to allow you to innovate and improve time to market. Again, we want to remove the undifferentiated heavy lifting and allow you to focus on your business problems. So let's start by talking about data collections. You may collect data from a variety of ways. You might have data from website logs. You might use public or private data sets, perhaps curated to meet your needs. The first question is, how do you get your data up into the cloud in the first place? Well, we have a number of solutions here. First, note that data ingestion into the cloud is free. So the only challenges are really technical. The first approach is just to stream the data. And if you can, stream the data in parallel. S3 supports multi-part upload, so you can get good results for moderate-sized data. For larger data sets, here are the options. The first is to use the import-export service. Sometimes it's faster to FedEx a hard drive or many hard drives than it is to use your network. Amazon is pretty good at dealing with packages, and so you can mail us your drives, and we'll copy the data from the drives to your S3 buckets and send you the drives back. For more dynamic data sets, we recommend leveraging a combination of virtual private cloud and Direct Connect. Direct Connect is a relatively new product, and it gives you a dedicated 1 or 10 gig link directly from your data center into our region. It's dedicated to you, it's not shared, and you can use that bandwidth for data uploads or downloads so that your cloud-related network traffic does not affect your normal network operations. Virtual private cloud is similar to our regular public cloud, but gives you more control over the network. So for example, it allows you to create subnets, manage IP addresses, and explicitly control the routing of packets within those subnets. Your VPC effectively becomes part of your existing data center, but can expand and contract as needed. Let's talk about data storage. So we provide a number of tools for data storage. S3 is our simple object storage, and it provides a simple put and get abstraction over buckets. RDS is a managed relational database solution. DynamoDB is a NoSQL solution. And EMR provides a HDFS-based distributed file system solution. So which one do you use? Well, it depends on the characteristics of your data. If it's structured and not huge, you can use traditional database technology like RDS to store your data. As the size increases and you begin to have to shard your data across a large number of systems, then consider DynamoDB, our NoSQL offering that provides adjustable I/O for your needs. EMR and HDFS provide horizontal scale that's well suited for unstructured data, log files and whatnot. And finally, S3. We have S3 for arbitrary data objects. Let's take a closer look at S3. It's a simple API. There's a get and a put, but it's anything but simple on its implementation. Today, we have over 1 trillion objects stored in S3, with some individual customers using tens of petabytes of storage. Once you put an object in S3, it's replicated across the availability zones within that region, and we ensure that there are 11 nines of durability. Each object is limited to 5 terabytes in size, but you can have as many objects as you want. The service itself is massive, with peak requests per second of over 750,000. So 750,000 objects per second are going in and out of S3. In addition, S3 supports multi-part upload, so you can upload your data in parallel chunks, and we support byte ranges for downloads, so you can download them in parallel as well. And just to reiterate, the objects stored within S3 have 11 nines of durability. So if you store 10,000 objects, the expectation is that it will be 10,000 years before you lose any objects. With over 1 trillion objects, touch wood, we haven't lost one yet. At about 10 cents per gig per month, it's a pretty good deal. So let's talk also about RDS, our managed relational database service. Currently, RDS supports MySQL, Oracle, and Microsoft SQL Server database engines. It's a fully managed service. We do the backups and the patching, and you can add master-slave replication across AZs. We handle the failover, and you can scale vertically by changing the instance type of the host. You can add read replicas at the touch of a button. As your data sizes increase, another option is DynamoDB. It's a NoSQL offering. Unlike other NoSQL databases, with DynamoDB, you don't have to worry about data scaling. You simply put and get as many key value objects as you like. We handle the sharding, we handle multi-AZ, and we handle the performance. We give you highly predictable performance using SSDs in the background. And in addition, we give you something fairly unique. It's a provisioned throughput model. So if you need 1,000 IOPS or if you need 100,000 IOPS, we give you that dial and you pay for what you need. As your application characteristics change, you can also change your provision throughput so that you can increase as the scale of your services increase. You can increase the throughput, or you can decrease the throughput to save cost as well. I'm just going to run through these real quick. So let me also just talk about data analysis. So Amazon Web Services also provides Elastic MapReduce, or EMR, to manage Hadoop service. As anybody knows who operates a Hadoop cluster, there's a lot of complexity in Hadoop, and EMR reduces that complexity by making it simple to spin up, provision, and scale Hadoop clusters. Last year, we operated more than 2 million Hadoop clusters for a large number of customers, big and small, startup companies as well as enterprises. We support, so EMR is Hadoop. It is not our version of Hadoop or something that looks like Hadoop. It is based on Apache open source Hadoop with additional capabilities to integrate to the other AWS services. EMR supports Pig, Hive, HBase, and pretty much any other Hadoop-based tool that runs on Apache Hadoop. In fact, EMR is the #1 enterprise Hadoop solution as determined by Forrester Research. We are very active in the Hadoop community. So I'm actually not going to talk about the share component, just in order to save a little time. But there are a number of tools for BI that we support that hook into our tools as well. So you can have data analysts who are non-programmers. They can access the data. They can explore and visualize large data sets and help them to produce insight over their data. I'll just real briefly I won't talk about security. I will just briefly talk about one case study, which is the Climate Corporation. So every day, this startup, the Climate Corporation, performs over 10,000 simulations of the next 2 years' weather for more than 1 million locations in the United States. It then combines that data with root structure and soil porosity to write crop insurance for thousands of farmers. I'll kind of skip over some of the details for that and just tell you from the basics, right? So they're taking 150 billion observations of soil types every 2 square miles of the U.S. This is public data from the U.S. Department of Agriculture. And they took data from the Doppler radar, also public data, and daily weather data as well, that are inputs to their simulations. In total, this data was about 200 terabytes worth. Using this data as input, they run thousands of simulations by spinning up a 5,000-node Hadoop cluster with EMR and crunching the data, exploring thousands of unique scenarios. The goal of all this work is to be able to accurately predict the effects of weather changes against crop yields and ultimately to offer insurance products to the thousands of farmers. So I hope that gives you a quick overview of big data-related services that AWS offers and how some of our customers are making use of these services. I'll hand the presentation over to Dan from ThinkBig, who will talk about the work that ThinkBig Analytics is doing with their customers utilizing AWS big data tools in insurance-related domains. Dan?
I apologize. Can you hear me now, guys? Sorry about that. I was on mute. So, again, my name is Dan Mallinger. I'm a data scientist here at ThinkBig Analytics. And I'm going to talk to you guys a little bit today about the work we've done in this and related verticals for big data and about our partnership with Amazon. So we've partnered with Amazon AWS to provide services around big data, helping companies get early velocity and engagement around big data, primarily focusing on offerings for education, envisioning, and execution around engineering and analytics. So we offer education through public and private courses. Our private courses are tailored to our customers and their particular needs, an on-site engagement with our clients. And we have public courses which may be folks who are doing it out of personal interest, maybe folks like you who are using their company's professional development funds to get a little bit of extra leverage and a little extra upfront learning as you guys start working with big data. We also offer envisioning services with Amazon, helping folks really develop a roadmap, figuring out how am I going to get to my critical business cases with big data quickly. And then finally, as a consulting firm, we do offer a lot of hands-on engagement work around engineering and data science, combining big analytics, driving value out of big data, ingesting big data, and turning it into real corporate value. So a little bit about ThinkBig. We're one of the fastest growing big data startups. We're a 100% pure play services firm. We have an increasing number of clients. We're well over 30 at this point. I think the slide is actually outdated. And we have locations all across the U.S. Our headquarters are out in Mountain View. We have offices in Chicago and Boston, additional presence in D.C., New York, Salt Lake City, Seattle, and Austin, Texas. So very quickly, what is big data? And at the top, we talked about volume. I think a lot of folks really understand big data as the idea of, well, if it's big, it must be of a certain size. But really, big data is more than that. It's not just about the size of the data. It's also about the variety of the data. It's about mixing unstructured and structured data. And it's about combining divergent data sets from multiple sources together to drive a real signal. And we'll talk more about the value of having those divergent sources of data and how they help you understand your customers just a little bit. It's also about velocity. So here, this diagram happens to call out the computational velocity, really being able to execute code quickly, getting close to near time or even real time. But it's also about business velocity. One of the core philosophies of big data, insofar as big data is more than just a technology, it's also a set of paradigms, a set of philosophies, a set of values. One of them is about business velocity, and we execute that through a core value of store everything. So you guys might be, storing data now. A common practice is to maybe have some data that's coming off the pipe, and you parse it, you extract the data that you have predetermined to be of most value, and storing it in an OLAP cube or whatever it might be. With big data, we say keep everything. And one of the reasons that brings real business velocity is that as you realize there's deep signal there, as you realize you needed that additional feature that you weren't parsing in the past, you have to go through the engineering cycle, reparsing out the data, updating your cubes, making sure it's getting stored in properly, waiting 6 months to have the critical volume of data. With big data, we say store all of it, process out the fields you need in real time, live, on a query side, and that way you never have those long delays as you realize there's additional value in your data. And in that sense, it's key to remember that big data and big data warehouses are a complementing technology. It's a complementing strategy. So they tie in to all of your other work, whether you're doing online transaction processing or maybe you're getting some very sophisticated mathematical modeling. There are key technologies you want to utilize, and you'll continue to maintain a lot of your existing technologies with big data warehouses sitting next to them, driving new value, new insights in complement to those. So insofar as I mentioned that big data has core values, that it is a set of philosophies as much as it is a set of technologies, I mentioned that one of those is having many divergent sources of data. So it's absolutely the case that unique sources of data provide unique sources of insight. And in tandem, they create a robust picture of your consumers, of the market, of whatever it is you're analyzing. Many of you are familiar with that through terms like 360 customer analysis. So storing all of this divergent data, whether you're talking about, transaction data, point of sale, social data, we'll talk more about that all together, and going through the process of creating big analytic systems is the big data process. And as we'll talk more, there's a key approach to that in terms of building from your basic reporting, getting new data in through a consistent data ingestion engine, doing some early batch processing, building up into analytics, and then continuing to enrich your data with additional data sets, and then driving it in through real multidimensional data science, really bringing in new insights. That is a full process to building big data applications. So when we talk about big data applications, you guys have, you've seen the headlines, you've seen the job postings, there are a lot of really big firms out there doing it. And there are even, some really exciting stories. One of my personal favorite ones, you guys might remember this story about Target that made all the news. So Target had, identified that a customer of theirs was pregnant as a teenage girl long before her father ever knew. And it's got a lot of buzz for all kinds of reasons. But the key thing is, right, we talk about latent demand. I mean, understanding the demand is there before your consumer understands the demand is there, before they realize those patterns are about to be executed upon, fantastically important and a huge gain. And the wild thing about it is, if you guys read the story, many of you will recognize that the analytics involved were not terribly complicated. They were using large data sets because it was really necessary, but they hadn't even gotten into the fullness of big data. So we're going to talk about how you can go even further with big data, with complementing data sources, with parallelized processing techniques, really deeply understanding who your consumers are and what's going on in your market. So with that, raises the question of, well, what is big analytics? We've kind of seen the use cases. We've seen kind of, some of the business flavor and some of the news articles. But what is it really? Well, it's data-intensive computing. Taking advantage, in this case, really taking advantage of the ability to expand in the cloud quickly lets you work with massive, massive data sets. Insofar you're starting with massive data sets, you're typically working with data you haven't seen before. You haven't been able to peer into deeply in any meaningful way prior. And so we start off with exploratory modeling, finding the patterns in these massive data sets, things we've never seen before, turning that into some baseline models, starting to get a sense of our hypotheses, starting to get some predictions down, maybe early on for some more simple models. Maybe we're doing some general linear modeling. Maybe we're using some Bayesian techniques. We're starting off small. We're iterating. We may at that point move into some live testing, thinking about scoring with champion and challenger models of testing. We also encourage a lot of our clients to think about introducing naturalistic variation, bringing a little variation into their systems to support pseudo-experimental designs. It's a little more complicated to make a link here, but there's some real value in introducing variance into your systems and leveraging that, and then using those extra degrees of freedom. So real-time, live, continue to refine your customer's experience as you continue to refine and expand upon your models, moving into more sophisticated techniques, whether it's massively parallel machine learning, or it's very specific and sophisticated techniques like structural equation modeling, really digging in deep and iterating quickly. And again, insofar as we had talked about those big data philosophies, storing all the data, using complementing data sets. That third critical value of big data is iterating quickly and easily. And that's one of the reasons we've really partnered with Amazon, is the ability to iterate quickly and easily in the cloud, to continue to add new sources of insight, new models, driving new data and new value. So very quickly we'll cover what does it mean to do some of this stuff? As we talk about exploratory and confirmatory analysis, iterating on models, a lot of exploratory analysis is really supported visually. And so using tools like Karmasphere, digging in with SAS for some folks, Tableau is another great visualization platform that has new and improving Hadoop interaction and experience. All of those are key. But an interesting story, if you look over here in the columns, we have many, 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 many tools that are out there. People are trying to find new ways to visualize data, big data, make sense of it. And the key thing is there aren't market leaders yet, right? You're pushing the envelope. You're doing new things. And because of that, you've got to be familiar with a number of tools, and you have to build nimble teams. And we're going to see a similar pattern as we talk about the confirmatory side of things, that need to be nimble, to be able to use many sources of insight. Whether we're talking about starting off with techniques that have less computational complexity, like general linear modeling, or maybe more computationally complex techniques, again, like SVM, getting into nonlinear optimization, then moving into things that parallelize and scale well, whether we're talking about random forests or collaborative filtering, naive Bayesian techniques, digging in, doing some interesting model with Gibbs sampling, estimating GOM with Gibbs sampling. We can really go deep, and we've got to have a broad toolbox to really leverage all of this new data and all this new signal. Again, the key is the signal in the data, really leveraging that. So as we do that, we have to think about what does it mean to build this data-driven organization. So think big. So far as we are 100% pure play services, we don't offer a real factory, but we describe best practices in executing big analytics that we describe as our factory. key things we work with people on in our engagements. So it's really starting off strategically, thinking about what is my strategy, what are the needs and requirements of my industry, my analysts, my clients, all across the board. Moving that into what it might be colloquial brainstorm, a process of identifying key use cases. What are the relevant data sources there? What analytic approaches might be best over those types of data sets? For each of those data sets, what development costs am I going to incur? What do I have to invest in? And then starting to select what are my early use cases based off success rates, early total requirement of investment, which ones are more long-term goals, and then building that into that process, going through, proof of concepts and pilots, engineering, going through QA cycles, and finally deploying production systems out to external clients as that final stage. And again, as we talked about, constantly iterating, improving, being adaptive, being able to always bring in new approaches to drive new insights. So insofar as you do that, what kind of capabilities do you need? Well, we've seen a value in that, when we talk about the need to manage networking and infrastructure and cluster provisioning, these very complex things, there's a real value in being on the cloud because you get all that for free. But you have a ton of technical requirements that you need to have there very deeply. When we're talking about data ingestion with, kind of the new era of tools like Flume that are kind of pure ingestion oriented, whether we're talking about ingestion strategies that are a little more robust and have the ability to do live messaging and adaptation and introspection through massive queuing, distributed queuing systems, whether we're talking about data transformation through Hive and Pig or the like. All of these are tools and services you have existing in your companies now. And so it's not just about embracing new technologies and just adding on to what you have. Insofar as you're complementing your technologies with big data, we're also talking about transitioning skills and adding complementing value to our existing personnel as we grow our company. And that's, again, something we work on developing strategic plans for as part of our Envision process. So as you do that, what are the real success? What are we driving through big data in this vertical? Well, it's helpful to start with a little bit of background. Big data really grew up in online advertising and marketing. And one key example of past client of Think Big is Quantcast. The Quantcast, for those of you who are unfamiliar, does direct measurement of websites. It's an interesting story because they're effectively estimating traffic to websites across all of the internet. And they do it through direct measurement, obviously providing a lot of value in the advertising and consumer segmenting spaces. And they solve a problem that hadn't been solved prior. So there's a problem of estimating traffic to mid-tail sites. And I'll give you a fun example. There's a great news channel in Philadelphia that's known as Channel 6 News. It's tremendously popular. It is a unique national case study insofar as if you're in Philadelphia, it's basically the only news channel you watch. Everybody watches that one. Interestingly, if you ask the big panel, the companies who estimate internet traffic based off panel data, they believe they got no traffic, about 1-2 people a month. When in fact they were getting so much traffic they were actually having trouble keeping their infrastructure up. And companies like Quantcast knew that. They were able to estimate it correctly because they weren't going off panel data. The problem, this is not to say you can't do your work with panel data. This is where it gets interesting, right? Complementing technologies, complementing approaches. Panel data works really well when you understand your sampling strategy and you develop an appropriate one. Big data, what Quantcast was doing, direct measurement, directly measuring everything, helped people understand where were those narrow strata. What sampling strategies actually work best over this long tail. And in doing so, we're really able to drive an insight that no one was. So we see a similar story with Ware, another past client at Think Big. So they were working with hyper-local recommendations, kind of thing you can only do with big data, understanding what's most local to individuals, what's relevant there, really driving lift in advertising through that. And in fact, that'll come up in a moment as we talk about the future and the current space of insurance. And so insurance, the vertical is already absolutely embracing big data and leveraging these themes. So whether we're talking about telematics, using telecommunication data, whether we're talking about the GPS in your car to understand kind of your traffic patterns, whether we're doing more creative things like you can imagine thinking about cell phone data usage during typical commuting hours and what that says about a driver, right? Real insights there. Whether we're going more traditional narratives of fraud detection, that's been a key story ever since we realized that numbers that end in 0 are more likely to be a sign of fraudulent accounting, right? It's been this recognition that there's deep signal inside activities that is actually very difficult to fake and becomes the real indicator of fraud. Whether we're talking about proactive offers, right? You think about Target and Target's ability to understand someone's pregnant, your ability to understand that someone's about to make a home purchase, buy a new home, buy their first home, move out of an apartment into a house. That's a key point to reach out to your customer and have proactive brand engagement based off that predictive analysis. Similar things around predictive maintenance and testing. It's historically been a very real thing in the insurance markets. Hospitals are getting more involved in it. Understanding on the basis of existing conditions whether additional testing might be warranted for kind of unrelated or seemingly unrelated conditions. You can imagine the same thing being proactively measured and provided to customers in the world of auto insurance. Similarly with dynamic pricing, understanding my consumer in real time. How frequently can I update people's prices? How soon can I give them the discount they need to make them a more valuable customer? Getting into basket optimization. So whether we're doing it as a firm that has multiple insurance offerings or we're doing it through partnerships, understanding how certain types of behaviors impact multiple insurance types is absolutely critical. So we can walk into some fun specifics of the future. So we already talked about hyper-local data, thinking about risk metrics. A great example is you think about people who have typically low-risk behaviors. They're not, by any of your surveys or any of their other behaviors, typically high risk, but you recognize where they live and where their office is forces them through 3 really nasty intersections on their daily commute twice a day, and they are much higher risk for accidents. And people give away that information. They give away through Facebook, through Foursquare, through all the myriad of social data applications. As you start to pull that in, you get a sense of not just those individuals' behaviors and their own propensity for risk behavior, but those that are kind of exogenous to the individual as a function of broader forces. Absolutely critical. Another key change that's going to happen, it's an interesting irony of insurance, is that insurance is really rooted in the group and that ability for the group to tie risk together. Because we think about risk-taking behaviors, we often leave the group out of it. What we know is that people assess how valid a behavior is on the basis of the group. So I'll give you guys another fun example, which is there's a great survey called the Reasons for Living survey. So looking at patients with depression and how do they describe why they would or wouldn't commit suicide. And the number one answer, worried about what others would think of them. Even in death, we look around and we say, hey, what would other people who I frequently interact with do? And although we don't do it consciously, we absolutely do the same thing when we talk about risk-taking behaviors. We talk about things like our responsibility to fulfill our contracts. Those are normative. Those are hyper-local to my group, my social group. And leveraging social network analysis to understand those dispositional and normative behaviors is absolutely a key complementing source of insight that we can leverage. Do the same thing, not just with social networks, but with social data generally. We know there are key indicators. Things like GPA are a key part of the application form for many insurance. But there are narrow strata within those. You might see someone with a high GPA who's actually engaging in very risky behavior that wouldn't be part of our form. And so a great example of that are the study drug crowds. So we think about that information. The GPA doesn't give it away. The social data, does absolutely start to tip the hand of the values and the risk-taking behaviors of the individual. Similarly, we can leverage these kinds of social data to not just think about risk-taking behaviors, not just think about normative values, but to think about consumer loyalty and brand engagement. So canonical use case here, as high SES individuals leave college, go to become customers for the first time, it's an early opportunity to get deep brand engagement, to build a long-lasting loyal relationship as these contracts tend to persist. Understanding that individual and their likelihood for engagement early on is something you can't do when you don't have market data. But an absence of market data does not mean an absence of data about the individual with things like social data, with other tools, and again, complementing data sets, really starting to build a picture of who your potential customer or your real customer really is. So these are all use cases that we work with customers to help think about, to engage in, to really find success with. And the process, generally speaking, is it varies, but one early example is to think about a jumpstart, really getting engaged early on, moving quickly. Within 2 months, having your data ingested according to a strategy with a key set of business cases in mind and executing on them. So that is how we execute something like that, what we call a big data jumpstart. Going through that envisioning strategy, creating a roadmap, going through multiple days of training, getting you guys up and running, able to have that handoff, all the while there's ongoing development going on to build up these systems, do the data ingestion, start getting analysis over them, and doing it in a way that, again, prepares you for ingesting even more data, continuing to add complementing data sets, iterating quickly, embracing all of those values and all those success patterns of big data. So I mentioned that we do education and training privately. We also do it publicly. I just want to give a call out. We'll be doing a class in Boston, October 30th through November 1st. We have a public training course in the Boston area. Please do go to that AWS training website below to check that out. And we'll almost certainly be in a city that your firms work in soon. We do them all across the nation and internationally as well. So keep your eye out for it. And if you have a need for private instruction, please do contact us. So that is all for me. I want to thank you guys for your time, and I'm going to hand it back to Amazon.
Great. Well, thank you, Dan, and thank you, Karen, for today's presentation. I'd like to remind folks who might have joined a little late, feel free to ask questions using the Q&A function in your browser. We do have time for a couple of questions, and I'm going to start off with pointing you back to Karen. Can you speak to how Elastic MapReduce compares to other Hadoop solutions?
Sure. So Hadoop is being developed as an Apache project, and there are a number of different distributions that are based on that, the Cloudera distribution, for example. What we provide with Elastic MapReduce is Apache Hadoop. So we have some additional connectors for making it easy to connect to DynamoDB, to connect to S3 and those things. But the version of Hadoop that we provide with EMR is the Apache-based distribution. But so all the other tools within the Hadoop ecosystem that work with Apache, the Apache Hadoop will work as well with EMR.
Great, thank you for clarifying. Our next question, I will point this back to you, Dan. Can you speak to what some of the challenges are that customers are facing when they're moving to the cloud?
Absolutely. So, for many firms, moving into the cloud is a new stage of development and a new approach for them. And I think the challenges are not just technological, but they're cultural and they're organizational. There's a lot of hesitancy to put data into, the ether. And so we've been working with firms to really help them understand the sophistication of security in the cloud and the really winning practices we've seen. So, whether we're talking about, FinQ is a great example of deep finance needs really being successful with the security in AWS and EMR. Similarly, for a number of clients we know who are investigating it around medical and other very secure verticals, as well as insurance. So as they get past that, it's a matter of really thinking about success with technologies in a space where you don't have to think about, in a space where you don't have to worry about provisioning. And that's the real success. That's one of the huge things. We have a client who, very excitedly talks about, scaling with revenue, not scaling in hope of revenue. And that's a huge win. So really starting to take advantage of the cloud and really changing the way you do your engineering patterns to move quickly, get tests out there, get experience, see whether or not something's working, and make adjustments quickly, as opposed to doing a 9-month planning and procurement process, again, with the hope of revenue. And I think that business flow and the ease it gives is actually, interestingly, one of the biggest challenges. It's a real paradigm shift, and embracing that and understanding how to work in that new paradigm and really find success in that new paradigm is the biggest challenge, and at the same time the biggest success we see our clients facing.
Terrific. Thank you for responding to that question. And Dan, I'll put this second or third question back to you. And wondering if you can speak to, from a customer perspective, how to manage or how to think about your current on-prem solutions when it comes to big data technologies. Do I have to consider moving everything to the cloud, or can you talk about kind of a hybrid solution?
Sure. So I'm actually going to ask that one of our principal architects who's really worked with clients and being successful in a big way on exactly that speak to it. So we have Daniel Eklund here, our principal architect. I'm actually going to hand this over to him because I think he'll give a fantastic narrative here.
Okay. Sure. I'm here. Can people hear me?
Yes.
Yeah, good. Yeah, I mean, this is a common question. We started Think Big as back early enough that the cloud and big data weren't yet joined together, and most people who were doing Hadoop were doing on-prem. They had their own data centers. They would bring in their own racks, and you definitely had to have a lot of operational intelligence because despite the statement that you can use commodity servers, they really weren't quite, quote, commodity. So a lot of people do have an investment in on-prem solutions, and there have always been, at least from some of the original developers of the Hadoop ecosystem, questions about whether the cloud could handle it. And you have to balance a lot of different things out. The speed of which development and operational aspects can be leveraged on the cloud make it absolutely a complementary technology. I really want to point this out. There are some companies who find it valuable enough to remove all on-prem solutions and move to the cloud, but more often than not, it's a complementary solution that's going on. Just like Hadoop as a big data technology is complementary to your existing MPP stack and your existing BI tools, your infrastructure should exist in a complementary sense as well. So if you have a strong investment in on-prem, cloud is an absolute key for being able to spike capacity, for being able to prototype technologies without having to order a brand new rack and deal with networking. Everyone knows how that goes. And definitely with Amazon's attention to details to make sure that, for instance, BPC, to make sure that on-prem and cloud talk well together in the networking sense, this has become a much more viable solution, the spiking to the cloud. Managing it, it's, VPC makes it part of the whole. Pretty soon the distinctions between what's cloud and what's on-prem are going to be lowered to the point where the fear that people had in the past about, oh no, this is on the cloud, will be, that's just another part of, quote, our network. So I hope I didn't ramble too much, but that's my feeling on that.
Oh, that's great insight. Thank you, Daniel.
And just to add a couple points to that. So absolutely that Amazon Web Services has really been focused on the enterprise market. So things like Direct Connect that we talked about earlier, the virtual private cloud, and also the storage gateway appliance that you can run within your own data center, really enable you to take your existing data center, expand it out as needed into the cloud, and shrink it and adjust it and dial it down, dial it to where it's appropriate.
Great. Thank you, Karen, for adding on to that. I think we have time for one more question, and I will direct this back to Think Big. And you mentioned the training, and certainly that's a great resource. Can you speak to how customers might think about learning about the big data tools, maybe speak to some resources and some areas where people can actually get some expertise and get up to speed quickly?
Well, this is Daniel Eklund with Think Big. Of course, we're going to plug our training. I mean, in the grants in there, for sure, we have training on your typical, let's say, relational paradigms and your big data warehouse paradigms, Hive and Pig being like the primary example of these. We don't necessarily have training on cascading and scalding and all the more cutting edge things out there, but we hope to make it easy for people to understand, because we're very focused on the underlying theory as well as being practical with the tools. We do also have a training that's specific to the machine learning libraries like Mahout that can in fact be run on top of some of these big data technologies. For most 90% of the use cases out there where people are concerned about doing joining, relational technologies like Hive and Pig suffice, and there's always self-study. I definitely encourage, and there are a lot of courses coming out there. Evaluate them as you wish. We of course find our course to be excellent, but that goes without saying.
Great. Well, thank you. And again, I thank everyone for your time, for joining us today. That wraps up today's presentation. And I'd like to thank Dan and Karen again for attending and presenting today. We will send a follow-up email with a link to this recorded session. And on behalf of Amazon Web Services and our presenters today, thank you for joining us to learn about developing your big data apps on AWS Cloud. Thank you.